Hey everybody, hope you're doing well. Today we're going to go over problems 5 through 8 on the Unit 8 review. We have a scenario where 450 people have been surveyed about what type of ice cream they prefer, and their gender has also been recorded. So we call this a two-way frequency table, and the totals are on the bottom row and the far right column. We're finding the probability of each event that we're given in the scenario for 5 through 8. So number 5 says find the probability that someone randomly selected likes chocolate. Okay, so you can do this a few different ways, but I like to just kind of use a highlighter. And I notice that there are 225 total people that could be randomly selected that like chocolate out of the 450 people who have been surveyed. And always remember, you want to simplify your answer, and that simplifies to 1/2. Number 6 says find the probability that a person randomly selected likes vanilla given that they are male. So that given word, remember, is helping me identify that there's a condition that has to be met. So the first thing that I consider is they have to be male. All right, so I'm just looking at this row right here. And my denominator is going to be that total, how many males can be chosen. So my denominator would be 250. Now, of those 250 males, how many can be selected that like vanilla? Well, I go up here and look at how many are in the highlighted column that like vanilla, and that would be 151 out of 250. Now, that does not simplify, and so that would be my final answer. In number 7, it says to find the probability that someone likes vanilla or is female. So if you remember, I've kind of already set this up with the formula for the probability of A or B. And so you remember you take the probability of one event, probability of A, plus the probability of B, but then you subtract the overlap where that's A and B together because we don't want to count them twice. And so I'll show you how this works as far as a table goes. I'm going to highlight the people who like vanilla, which would be this row right here. And then I highlight the people who are female. And where that overlaps is that 74. Okay, so you can do this two ways. I like to follow the formula because sometimes I don't have a table or a frequency table that shows me visually how to solve this easily or quickly. And so the probability that someone likes vanilla would be this total 225 out of 450 plus the probability that someone is female would be 200 out of 450. But I have to subtract where they are vanilla and female at the same time because I've kind of counted this number 74 twice and I need to subtract it, the overlap. All right, so that when you add those together, I end up with 351 out of 450, which simplifies to 39 out of 50. And you can always double check yourself and just add the three numbers that would be considered in this scenario. So you could add 151 plus 74 plus 126, and you should still end up with 351 out of 450. Hopefully that was helpful. All right, looking at number 8, find the probability that, it says are being male and liking chocolate independent events. So the first thing that I did was write down the formula for independent events. So the probability of the two events where they intersect needs to equal the probability of the first times the probability of the second. So the probability of being male and liking chocolate should equal the probability of male times the probability of chocolate. Okay, so the probability of being male and liking chocolate at the same time, I find where those two categories overlap, which would be 99 out of 450. And I'm going to see if this is equal to when I multiply the probability of being male times the probability of liking chocolate. If these two things are equal, then they are independent events. So I'm going to take and find the probability of being male. That is 250 out of 450 people selected because there are that many males. I'm going to multiply it by the probability of selecting someone who likes chocolate ice cream, which would be 225 out of 450. Now on the left side of my equation, I have that probability of being male and liking chocolate at the same time is 99 out of 450. And I'm trying to see, does it equal the same as 250 out of 450 times 225 out of 450? And when I multiply those together, I notice that they equal 5/18, which does not equal 99 out of 450, and so no, these are dependent events. Hopefully that helped you with the next section of your review. Keep on working hard, and we will see you back here tomorrow for problems 9 through 12.